Okay, so in this video we're going to talk about the master cylinder to help you complete your task sheets during your distance learning. I'm going to email you a PowerPoint that we're going over in class, but the master cylinder, there's something that's got to kind of be explained about the PowerPoint, so that's kind of what we're going to go over here. Our master cylinder here, plastic reservoir, cast iron body on the bottom. If you read on it, it says this uses .3 fluid, only from a sealed container, because brake fluid is hygroscopic, like the PowerPoint's going to explain. That means it absorbs water. So if you leave the caps off of a master cylinder or the container open to the atmosphere, in other words, without the lid on it, it will actually pull moisture out of the air and absorb it into the brake fluid and makes the brake fluid go bad. There's an electronic tester that we test brake fluid with that will tell us the water percentage in it. So anything more than 2% tells us it has to be replaced. This master cylinder is setting right on that 2%. The fluid looks kind of discolored, and you can just tell by looking at it that it needs to be changed. So let's talk about this master cylinder and a little bit about what goes on in it. We've got a primary and secondary lines coming off of it for our split system, like the PowerPoint's going to talk about. So in this master cylinder, this is the slide from the PowerPoint. On the end here we have the plunger that's coming in from the booster, which is connected to the brake pedal. It's going to engage a primary piston when you start pushing on the brake pedal. There's some little ports right here that are open all the way down to the brake component, whether it be a caliper or a wheel cylinder. So when you're not applying the brake, this is open so that all the fluid and pressure can return from the brake component just back into the master cylinder reservoir. So as this starts to move and closes off that port, any additional pedal movement will generate pressure. There's fluid between the primary and secondary piston in here. So that fluid starts to move. It moves this piston and seals off the secondary from the same port going into the reservoir. And then from that point forward, the harder you push on the pedal, the higher the pressure goes in the brake system, so the harder the brakes will come on. That's why you can do a light brake application, or the harder you push on the pedal, the more brake application pressure you have, so it gives the driver kind of a feedback that our air brake system we've been talking about doesn't have. So you actually feel the pedal pushing back with the hydraulic force, the harder you push on the pedal. So in the event you had a leak in the secondary system somewhere, the primary is going to build pressure, but it's going to have to move farther to do it, because it has to seal off over here. So you'll have a low pedal, same as if the primary is leaking. You'll still have secondary, but this has to travel farther because there's not a good solid fluid coupling in between here to make this piston move as soon as the primary moves. So once again, you'll have a low pedal and a brake warning light on through your pressure differential. The task sheet's going to have you check for leaks on the master cylinder. So at the very back of the master cylinder, where it bolts onto the booster, there's actually a little groove machined out right down here in the bottom, so that if this seal back here leaks, you'll have an external leak on the master cylinder, and it will run down and drip off of the booster or down the firewall, depending on how it's mounted. So you'll have an external leak back here. Other external leaks will normally be occasionally one of the lines here leaking where they connect, or there's rubber grommets inside where the reservoir connects to the master cylinder, so those grommets can leak and leave the master cylinder itself kind of damp and wet and drippy with brake fluid. So that's what you're looking for on external leaks. Now it's going to ask you to check it for internal leaks. So what an internal leak is, if our primary seals here on the piston or our secondary seals, either one, start to leak on a master cylinder, it leaks internally. So what it leaks is pressure, because it allows some of the fluid to get back past the lip and return back to the reservoir. So it doesn't leak externally, you don't lose any fluid, but your complaint will be when I push on the brake pedal, as I hold it, say I'm sitting at a stop sign or stoplight, the longer I sit there, the farther the pedal drops down. That's an indication of an internal leak, which is one of these seals, either here or here on the secondary, allowing fluid basically to kind of bypass back to the reservoir and leak past the seal. That's why it's an internal leak. So once again, the pedal will drop as you hold pressure on it and continue to drop basically until it eventually reaches close to the floor. So that's an internal leak on the master cylinder. We didn't really talk much about the reservoir here. So everything now pretty much has ABS brakes on hydraulic. So this reservoir is split. The top half of it is open, but about halfway down it has the divider, so that a leak in one half of the system can't completely allow all the brake fluid to leak out. So it can leak down to a point, it shares a reservoir, but then it's sealed off in the middle basically, or it has a divider, it's not sealed off, but it separates primary from secondary. And once again, if you notice, primary is closest to the pedal or the firewall, just like in our air brake system when we were talking about that. So primary is always closest to the pedal. The other thing this reservoir has, this connector here is in the middle of the reservoir, so it is connected to a float that tells the computer for the analog braking system that we have plenty of fluid in our reservoir. As the fluid level drops, this float drops down and it will turn a light on in the dash and will give you a brake warning light, a red light, telling you there's a problem with the brakes. And then it will also give you a ABS light, because anytime the ABS light comes on and stays on, that means the computer has saw a problem with the ABS system, and ABS doesn't want to cause a wreck. It knows everything has to be working right for ABS to work right. So it knows that if we have low fluid, that could be problematic. So if the ABS sees any kind of problem with either the fluid level or the system itself, it turns the amber ABS light on. Anytime that light is on, the ABS is turned off. So the computer takes itself offline and says, we're not part of this game right now. We've got a problem. So we don't want to become a bigger problem. So we're out until it's fixed. Our little amber light's going to stay on, letting you know that we do not have any ABS brake function. We just have normal foundation brakes. So if the ABS light and the brake warning light is on, the first thing you want to check is for a low fluid level here. So just take the cap off. You can see if it's not really old and faded, you can generally see through the side of the plastic where the level is. Most master cylinders will have a little mark that says like max and minimum to tell you if it needs fluid. Not all, but most do. So anyway, got to have the fluid in it to turn the light out so that both of those lights go out. As far as on the F350 that you're going to do your task sheet on, the brake warning light stays on because it is low on fluid. So both the ABS and the brake warning light come on after the self-check, meaning when you turn the key on, it runs a self-test of the ABS, just like our air brakes did. So both of those lights should come on initially with the key, let you know the bulb is working, and it runs a self-test, and then both of those lights should go out, especially when the engine is running, as long as there's no problem. So the brake warning and the ABS light both stay on the F350, so there's your problem, and it's from low fluid in the master cylinder.